see my screen. So I'm Ewan Miller, I'm CTO OpenCRVS, and I'm here with Bevolve, and we are looking at the back end of OpenCRVS. And so we're just going to be doing a very informal kind of discussion about the back end code and what's going on when we're creating registrations, what happens in databases, what are the relationships between collections and all of this sort of thing. And when we're sort of looking at the code of any project, it's kind of half architecture, half history lesson. I'm sure you kind of appreciate that over the years, things develop in a very organic way, and ways in which we've done things in the past, we might realize through the usual process of project development. You build something with an assumption, a set of assumptions, and then you kind of realize later on when you have more data, more information, that maybe you need to change how things are done. And you can sort of see that, of course, in any code base. You can see the evolution of ways of doing things from one way to the other. And hopefully this will kind of shine a light on some of those aspects of the back end of OpenCRVS. And it would be really nice to also do another meeting where we could talk about the front end of OpenCRVS. And if there's any questions which I'm unable to answer, then we could bring in specialists in those areas to really focus on a particular point. Because, you know, my knowledge is pretty high level in a sense. So, first of all, we're wanting to sort of take a general look at the whole project module-wise. So what I've got open here is, if you can see my screen, is OpenCRVS Core. And inside the packages directory are all of these folders. And most of them are microservices. One or two of them are shared libraries, and one or two of them are little helper things. But mostly every single one of these folders is a microservice, and you can tell by looking into it, and you can see you've got a Docker file. So you know that this is going to be a microservice part of the OpenCRVS stack. So I'll go through these very quickly because it's quite straightforward. The names make sense. So the auth microservice, that is the microservice you're communicating with when you're logging in to OpenCRVS. It used to be in previous versions of OpenCRVS, before OpenCRVS 1.5, that we'd be communicating directly with auth. But now, in order to protect against, we've added in rate limiting as a security improvement. And now actually all of the requests to auth are proxied through our API gateway, the gateway microservice. So this is a combination of GraphQL, Apollo client, and REST endpoints. So you'll notice in the gateway a combination of those two approaches. So the gateway basically will handle all of our API gateway integrations. It is the single point of entry to the backend. And you'll notice, of course, the client, which is the React application, the main React application, and I went to it via the login, which is another client React application. Then when we are, once we are, the only ones which are exposed via traffic are gateway, client, and I think metrics, which we use to expose some vital statistics export endpoints, and webhooks, which people can subscribe to. The rest of the microservices are all internal. And of course, there is another microservice which isn't in this repo, and that is the country config microservice, which you're well aware of. This is your configuration microservice for your country. So what this does is as you know, we have all of our kind of reference data, our form configuration in here, and the gateway when we're logged in. The config microservice is also exposed. So we'll be calling config, and the config microservice will call the country config microservice, and then get the application settings, the configuration back into OpenCRVS Core, and then distribute that configuration as required to all the other services to give them the specific parameters that they need. So when we are making a registration, so if we're in OpenCRVS and we complete the form, I'm just working locally here, I'll just put in some rubbish, so we can just get quickly to the database. So let me just complete the form briefly. So when we submit anything, we are sending that in a GraphQL request to the gateway, which you can usually see in the network tab, that being sent off. And it goes to the gateway, the registrations, and then the gateway decides what to do with it. And usually it forwards it straight to our workflow microservice. And the workflow microservice will then communicate with the database to find and look at the payload and decide what data to put into all of the databases based on the registration form that was completed. So the workflow manages state transition for the application. So if you are a registration agent, for example, you submit drafts, applications, what we call declarations in civil registration terminology, to a civil registrar, who then can review them and register them. So you can imagine there's a state transition between a declaration that's submitted to one that's validated, to one that's registered, to one that's certified and issued. The actual print is given to somebody in the field. And then there's many other different states that it can go through as an optional basis, depending on the user. So you see some of that state transition discussed in our documentation. So you can see these are all the states, the squares, and they go through transitions depending on who is doing the action, and so depending on the users. And so the workflow microservice will be checking who's submitting this, what state is it in, what state does it need to transition to. And so you can see a lot of that described in the states file, TypeScript file in workflow. You can see what is the state tree, what are the allowed transitions that can happen for a registration. And if you were to follow the code from the gateway all the way through, you'd see various checks about who is the logged in user, what permissions do they have, etc., in order for the correct transition to be made. I'll go into this in a lot more detail in a moment. But first of all, that's kind of high level what's happening in the workflow. So the workflow manages the state transition, and then will dispatch commands to, for example, save in the database the state, the audit trail. You know, this state was moved from one state to another by this individual, and the action was made on the record. So what we see in the databases in the back end is we'll see that that audit trail, and it's retrievable from the data layer, which is hearth and fire, as a fire composition. And the fire document section, event composition in our documentation, gives you a bit of a high level about what that composition fire payload looks like. So you could see that a birth application was made, that there was, and we use the same fire terminology in the healthcare setting. So there was an encounter between an individual, an informant, and a member of staff, and that member of staff created patients, you know, children, mothers, fathers, and there were supporting documents uploaded. There were observations made on the actual composition itself can be far longer, where we see, okay, this who was the attendant at birth? It was a physician. Who was, you know, what was the body weight? It was this kilogram value, for example. So the observations made on the child, all of this is kind of saved in a kind of slightly customized version of Fire for our server registration needs. So most of the time you'll notice it's the same as Fire version 3, but you will notice from time to time we've had to create extra extensions in order to support the requirements of server registration. Why did we do that? Well, there's a history to the project. You know, we started this in 2018, and there was no server registration standard. There still really isn't. There is one called the Digital Convergence Initiative, DCI standard, which has started. We've been very much involved in directing that. We're core contributors to it, and we've been showing them what we've been doing in Fire in order to create an interoperable server registration standard, which interoperates with this kind of customized version of Fire. So that's why we had to do it, because a standard didn't exist for server registration, and we thought healthcare gave us the most flexible standard at the time. So workflow is then dispatching these actions to different places with the composition and saying, okay, do with this composition what you will to the other microservices. So these are all the actions that have happened on the composition. The search microservice is pretty important, the Elasticsearch. This is what is Elasticsearch, and the search database is what you see when you look at any of the work queues. So anything I'm seeing in here is coming from Elasticsearch. So it contains the status of the record. That's really core concept. Elasticsearch always has the current status for the record, and it has some information. It actually has the name, it has the registration number, the date of birth, place of birth, and a couple of other bits of personally identifiable information, but not the full composition. We've tried to keep the Elasticsearch, what's stored there, as small as possible, so that when we do deduplication, we just check Elasticsearch. We just say, this registration has come in. Are there any duplicates based on the birth? And what we decide, how we decide to do duplication check is currently hard coded in core. And you know, we can we have a backlog item if people want to configure it, but we tend to find that the child's name, the child's date of birth, the mother's name is enough information that we can check a fuzzy match on the child's name, a fuzzy match in the mother's name, the date of birth. And then if we can find a match from that. If in your form configuration, you're doing things like tracking identifiers like that mother's national ID, then that also is included, identifiers, as a must match. But of course, not every country does that. So it really is dependent on the country if they're asking that sort of ID question in the form, whether that sort of deduplication can work or not. So Elasticsearch allows us to do deduplication. It powers this search interface and the advanced search. We're searching directly from gateway to search, or deduplication directly from gateway to search. And the Elasticsearch is the status. So you can think about it as we have our Fire database, which is in so there are a number of other microservices that aren't listed here, which are open source projects. So this is quite a dump of information. If you want to stop me anytime and ask a question, please just raise your hand and ask a question. But if you look at our Docker Compose files, you will see a few other Docker Compose.deps dependencies. You see, of course, every one of these is also a microservice that runs, but these are not ones that we built. These are ones which the open source community made. So, of course, we have Elasticsearch, we have MongoDB, we have Redis, we have influx data. We'll come to that in a moment. But the most important one to think about is Hearth. So Hearth is a Fire standard database server written in Node.js on MongoDB. And that was again, going back to the history of this project. OpenCRVS started with a collaboration between an organization called GenB Health Systems. And GenB Health Systems are a healthcare open source development organization. And they developed OpenHIM, the Fire standard interoperability layer. And they were working on a project called Hearth, which was a NoSQL Fire database server. And they ceased that work. They were directing instead over the years, they stopped working in Hearth, and instead they directed their attention to OpenHIM with the view that one day they might go back to it, but they were seeing in the Fire world more movement towards Happy Fire, which is a PostgreSQL database. We didn't want to migrate to Happy Fire because we liked using NoSQL. We saw that we could potentially, if we stuck with NoSQL, enable horizontal scaling that we couldn't do if we went down the PostgreSQL route. So we saw that as being not the right strategic direction we wanted to go in. So instead, we took over the maintenance of Hearth. We don't publicize that we do, because we do it solely for OpenCRVS. We're not doing it for any other organization. We're not doing it for any other healthcare support whatsoever. We're doing it only for OpenCRVS. So you'll see that it is coming from our repo now, and we make sure that this patches are all up to date and that any zero-day vulnerabilities or dependencies are upgraded. So we're using our version of Hearth. And so the workflow, as I was saying, it sends some of that composition data to search and the full Fire information to Hearth. So if you're looking at our database, I'm using Robo3T here. If I just refresh, you can see all of our Mongo databases. So the Hearth database is called Hearth Dev, and you'll see a number of collections in it. So what you might notice here is the people who designed Hearth, so GenB, actually designed it in a kind of an SQL kind of way with lots of tables, related tables. And so you can see we've got the composition. So you can see the composition for the as Fire, just native Fire JSON. or the birth declaration in there. So you could see we have some values in here, like the tracking ID, the birth registration number would go in here when it's eventually registered. And you see sections, and in each section you'll see the informant's details, and the entry would be a fire ID of a related person. So this is the informant, we see a related person, and the mother's details, you'll see these as actual patients, fire patients. They have a fire ID, and that maps to the patient collection, and then you'll find the actual name of a patient. So again, I just put rubbish in here when I was testing. Birth date, all the stuff to do with the fire patient object. So GEMB decided to have separate collections for every single fire native object. And I'm sure they did that for very good reasons, for the multiple use cases that healthcare would need. But actually, from our point of view, we don't really want to retain all of these collections. We'd like it all to be in just one collection and then make it horizontally scale it. So that is our plan. That's our strategic plan over the years to come, is that we're going to refactor this and refactor out as many of these collections as we possibly can. We will keep some. We'll keep things like location. This is for administrative structure, offices, hospitals, etc., because we still want to be able to have a distinct location API, and we have a number of reasons why we want to retain that one. But the things to do with fire patient composition and counter observation, we'll probably combine them all into one, and that will allow us to really easily horizontally scale the record, the civil registration record. So that's our plan to do that in the future. So workflow, as I said, sends partial information to search, and the rest of it goes to Hearth. Or the same information, but just duplicated in two different places. So a minimal set for searching and dedupe in Elastic, the full set in Hearth collections. So there's a few other microservices just to talk about here. And let's talk about metrics next. So this is another data layer, part of the data layer. We talked about Elasticsearch, we talked about Hearth. The other data layer is all to do with analytics. So if we, in OpenCRVS, click on the performance view, again, this is going to be a bit of a history lesson about business intelligence. So we know that there are some users in statistical departments who would not have the legal right to see personally identifiable citizen data, but do need to see statistical data in order to inform government policy, the statisticians in the government. And we wanted to display, previously civil registrars had nothing. Like if they wanted to get statistics, they're manually looking through books and writing them down, printing off lots of pages, or some vendor solutions might give them, they might have to access the database directly, do a database dump. And we thought that's not secure. We don't want people to access databases directly. We want to give them something that allows them to easily tell the story to the governments about what the registration rates are in their country, for example. One of the most important ones is the completion rate. This is, the number of births in a country for every 1,000 people expected versus how many have they actually received. That is the kind of core metric in civil registration, to know how successful your civil registration program is. And we thought, well, we'll use React and we'll do some really nice kind of graphs with D3, and it'll be lovely for them to visualize, and we'll do this all custom based on interviewing lots of civil registrars and asking them what they need. And we know this has to be time-based because people want to see how is my completeness rate changing over time. Last year it was 53%, now it's 54%. Therefore, we're thinking, right, time series. Okay, we need a time series database. That would be the best way to track these metrics. So we chose influx data. So you'll see that in our dependencies, InfluxDB. So influx data, you probably heard of it. It's a very famous time series database, open source. Great, we'll use that. That database it's the metrics microservice, which is communicating with it. So the workflow will have dispatched the full bundle to search and metrics will get that bundle and then they'll go, right, okay, I need to pick out the gender. I need to pick out the location, the file location ID. That's all I need. And the dates. And maybe other things, like we could do all sorts of business analytics, such as how long did, let's try and find out what I'm trying to say here. Yeah, I need to go to an office. So if you're looking at a district or a location, you get kind of, sorry, if you're looking at a district or a state, you're getting state-based analytics. But if you look at an office, then you're going to get some other things to do with your actual performance within your office. So for example, for field agents, for example, how long did it take them to complete the form? That's quite useful to know because you could say, we're asking too many why are our registration rates low? Well, because community health workers are spending too long filling the form out, or they don't know how to answer certain questions. And we can track, which questions were completed, which were incomplete, how many, and that information is all there. So we started tracking some more operational metrics as well. So nothing to do with PII, but how well are our staff performing? How well is our birth registration form performing? And you can see, how many records have we got in certain queues, etc. And then where are there blockages in the flow? Why is it that records are not moving from one status to another fast enough? We're trying to think about these sorts of operational training that people could do. So all of that stuff is also in InfluxDB. So if you were to look through this code, you'd see all that sort of statistics being pulled out of the bundle and saved into influx data so that we can represent them in this custom interface. Now, history lesson's going to continue because, right, on analytics, because we go to countries and we show them this and they go, oh, that's great. Can we have this? Can we have that? Can we have this? And we have to then think, okay, but that means we're going to have to, in React, make more React graphs, more D3 graphs. We're going to have to write more requests. That's quite a lot of overhead. Let me log in as a performance user to show you something else. So I'm going to log out as a registrar. I log in as one of these I think I'll log in as, yeah, let me see. You can log in as a performance user. You wouldn't see the registration work queues, you just see the statistics. But I'm going to log in as a national registrar because they can see everything, just to kind of give the fullest picture. So we were thinking, how do we solve the problem that countries are going to ask for stuff that we're not currently doing? Well, we got two solutions for that. Our first solution was, let's generate a CSV file of all of that non-identifiable data from influx data and Hearth we could pull from both locations, get everything that's asked in the form, that's nothing to do with names, dates of birth, addresses, anything that could identify an individual, and put it in a CSV. And then people can download them every month, and they could open it in RStudio or Posit, whatever statistics tool they want, and generate whatever kind of graph they want. So that is something they could do like a database dump, but without the PII or without accessing the data. So they had that option. But then we still saw other countries saying, oh, why can't we use Power BI? Why can't we use Metabase or something like this? And then build our graphs that way. So great, okay, let's support that then as well. So this is where the dashboards came in. I'm not running them right now locally, but you've obviously seen them before. The dashboards use Metabase, and that uses this SQL database, which basically essentially is querying the same sorts of things that you see in this VS export. So that's another aspect, that there is an SQL data layer for Metabase. It's meant to never contain PII, but of course, it's really up to the country what kind of query they want to make. They can customize that query. They could decide to do so, but then they need to be aware that whoever accesses that PI needs to have the needs to be legally allowed to see it. It's meant to just be for policy, statistics, operational metrics. So that's the metrics microservice and the Metabase dependency, which I think is kind of loaded up in the country config. Why did we put it there? Because our vision for it is that one day we will have a data lake, that metrics, we will deprecate what we have in InfluxDB. We won't necessarily say we're going to give you support Metabase queries, but our strategy is we'll have a data lake and people can use whatever they want. We'll make sure that our Metabase example still works for migrating countries. But if you wanted to use Power BI, you just connect to the data lake, you pull down the data, you do in a standardized format, and you do whatever you want with it. And then that would mean that anything will be possible. And what we'll do with this React UI is we'll try to make it much simpler, just the real basic needs, and direct people instead to use Metabase or some other tool via a data lake. So you'll notice that in our backlog. Because maintaining this over the long term is just, it's too much of a drain on resources. Better people have the flexibility to do what they want. So that's metrics. So a couple of other microservices to talk about. User management. So this is obviously the auth. When we authenticate, we want to get the user details. We want to make sure their passwords are correct. Want to find out what role they have, what scope they have. That's all contained in the user management microservice. That's where that communication happens. And you can see that it has its own Mongo database, its own collection called users. And this is where you can see all the user information, what role they have, what scopes they have, etc. Now, at the moment, as you know, you can't really configure our kind of system roles are hard-coded. You know, we have field agents, we have registrars, registration agents, and they do these sorts of things. And part of your business analysis is always, right, I've got to talk to the country and I've got to say, what do you call the equivalent of a field agent? And then you kind of give it a label, you know, depending on what language you use to describe that system role. And you know, you might come across when you're working in Tonga or in a country in the future, they might say, oh, we want to have this kind of user who has these permissions. How do we do that? And at the moment, you kind of have to shoehorn them into our OpenCRVS roles that we have designed based on asking lots of civil registrars around the world how they work, asking UN how they advise to do civil registration. But we want to make this configurable, and there is a ticket in 1.7. So we're working on it right now. We're taking all of the scopes that are in the JWTs, anywhere in OpenCRVS code that's saying if this scope, do this or do that, and move it like we've done with the state transition into into the country config microservice. So when 1.7 comes out, you should be able to entirely configure any kind of user that you need, we think, and also configure the work queues to show a specific type of search. Why are we doing that? Well, because we've been asked by countries like who have decentralized models. In our country, registrars are only allowed to register within their state. They're not allowed to pick up. At the moment, you can search nationwide. So that's quite useful. If you imagine operationally, somebody could start a registration in one part of the country, move house to another part of the country, and they want to pick up the registration and continue with it. But that makes sense to the customer. But legally, in some countries, they're not allowed to do that. Legally, in some countries, no, you have to register in that district where you were born. So it doesn't matter where you live now. You've got to go back to that district and do it. Until the law changes, that's what we have to do. So we want to support that. Obviously, we want to say, look, it's possible to do it in a national way. But of course, if you wanted to restrict registrations to only happen in an area, within these, currently these work queues are all about a single office, right? But if you have a state registrar, you kind of want to see in here every single registration in your state. So that would involve you customizing the search query, Elasticsearch query for that work queue. So that is why we're adding in that configuration as well with the user configuration. So you'll be able to do sort of office hierarchies and configurable user permissions. And this will all be kind of closely related to what's happening in the user management microservice from the country config and search. So that is user management. Then another microservice to talk about probably is some very simple ones, documents. So history lesson, we used to store our documents directly as base64 in MongoDB back in like OpenCRVS 1.0 and 1.1. Not a very effective use of resources. Much better to have like an S3 type document store. And that is what documents is. It's a database server for the dependency Minio. So Minio is an open source blob storage system. It's S3 compatible. So the reason that's quite good is that if we imagine as we start to scale across a country, we've got hundreds of millions of registrations, and each one has 600, 400K attachments or 5, whatever. Excuse me. You can imagine that you could get a situation where you've got, like, for one record, a couple of megabytes, and then multiply that by a large population size, and you can see you're going to need terabytes of storage data. So if we had a way strategically and legal agreement to use the cloud to store attachments, then we could move just the attachments onto Amazon S3, not the rest of the citizen data. But I don't know. That would obviously be up to the country to decide if they want to do it. Otherwise, they're going to have to pay for more storage. But at least having Minio and a dedicated blob storage, which is compatible with S3, it gives the country that avenue that they can use. So, and we're no longer storing documents as base64 in MongoDB. So you would see in the previous version of OpenCRVS, like in the fire document for in previous versions, where you get to the actual body of the document. Sorry. Let me see. They're not listed here, but we have a lot of work to do to fully document in here what we're doing with fire. That's just in our backlog of to-do items. The best thing you can do is actually look at the database yourself to get the actual full JSON. But it used to be that when we were looking in hard dev and we were looking in the document reference, I didn't upload any attachments when I was doing my birth registration form, but you'd have seen one there. You used to see base 64. So that was obviously a waste of space. So now you just see a Minio URL to Minio. So that that is when the client's requesting an attachment, goes via the gateway, goes via documents, or I think it may even be exposed. Minio might be publicly exposed. It's secured. You can't get it outside without a JWT, but it's there, I think, or it's like a really random UUID. So anyway, that is that documents. Anyone that not covered, dashboards is the one that talks to Metabase. That's where your Metabase configuration is. You know that. I think that's where you do that. Notification. So when you are submitting declarations, registrations, you know that you want to inform the mother and father the status change on the record. So they know, oh, okay, my record's being validated now. That's nice. I've been kept informed of what's happening. My record's being registered. Great, I can go and collect my certificate. So the reason we do this is one of the biggest problems in customer experience with civil registration is people having to go back and forth to civil registration offices because they don't know what's happening. And that costs them money and they think, I don't want to do it. I can't be bothered. I'm not going to register my child. If we can keep them informed and they know when it's ready, then they'll come in and collect it. So notification microservices, every time workflow makes a status change, it will say to notification, send the appropriate message to the informant based on the status of the record. So that's what notification does. It handles that request and chooses whatever languages are being used in the app, and then broadcasts that to your country config microservice, at which point you receive it in the notification API, and you decide to either send an SMS or send an email or do anything else you want. You could decide to use WhatsApp or Telegram, anything you want. So that's the integration point there for that. The final migration. Okay, so there's a few things here which are not microservices. Well, they might be, but very temporarily. Migration's one of them. It has a Docker file. The migration microservice has in it all of the database migrations like we've created when we've made new versions of OpenCRVS. So when we've changed the Mongo models, we write a database migration and you don't have to run them. Normally you might have like connects or something like this and Postgres, and you've got static migration files, you've got to run them manually every time you upgrade. And we researched and we thought, oh, this is a big reason why people don't upgrade digital public goods, because they have to understand how the migrations work, and that's complicated and scary. So why don't we just automate it so that people don't have to run them? So we write these migrations, we test them on our servers with a bunch of test data to make sure they don't fail. that doesn't mean that they won't fail on yours if you've done things differently. So always a good idea when you're doing the upgrade, when you do that first deploy, log into Kibana, search for tag migration, and you'll see those migrations running, and you're making sure there's no errors, that nothing pops up. If there's no errors, you're fine. They've all migrated. You don't have to do anything other than that. Just check the logs. So when the migrations have finished running, they run on every deploy. So they run over and over again on the same stack. They don't, but they know if they've been previously run, so they don't have to run again, as you can imagine. So once they're complete, the Docker container just shuts down to save resources. So that is a microservice, but just a kind of one that runs on deploy. Scheduler. This is one which the cron tab uses. So obviously we have Metabase. Right, what does Metabase do? It runs an SQL query against your whole database and your whole hearth, and it picks out the bits of information that it wants, runs a Mongo query. Now, if you're working in Tonga, there's no reason why you can't do that in real time. The population is so small. But if you're in Bangladesh or Nigeria, you've got millions of records. If every time you did a registration, you're running a Mongo query in the whole database, you can imagine that the performance of the application will get very, very slow. So in production, the cron tab will run these shell scripts to generate the metrics, the Metabase data, and to generate a line in a CSV for the VS export. So that's what the scheduler is doing. It's just there to help us generate metrics in a way that will not affect the performance of scaled countries. If you wanted to in Tonga, you could disable that only running on production. You can make it run in QA, or run on any environment. But of course, then you're forking core to make a change, and we kind of don't recommend you do that. We recommend you just say to Tonga, when they're looking at performance data, this stuff from Influx is real time. Metabase vital statistics is 24 hours old or 12 hours old. It happens at midnight. That's all. So it's not a big ask for people to kind of wait. They get real stuff here, real time stuff here. They get 24-hour later stuff in dashboard and vital statistics. So we're making a row in this, by the way, in this one, we're making a row in a CSV every day. But you don't see it every day. You see the final CSV every month. It was just the user interface that the design team felt was best. Being able to download. Okay, eventually you'll see up here August 2024, September 2024, November 2024. There was a request to do it in years. But the thing is, if we did it in years, the CSV could be millions of lines long and actually too big for something like RStudio to import. So that's why we chose to do it on a monthly basis. So again, all these history lessons that happen with everything that we're doing, there's always a story behind it. Webhooks, this was asked for by MOSIP, so the Modular Open Source Identity Platform. They wanted to be informed whenever a registration occurred. And they said to us, we would like to be informed in a standardized way using webhooks that we can subscribe to. And this was before there was any kind of initiative like G2P Connect, which is an amazing initiative by the Center for Digital Public Infrastructure. And they've now defined a standardized API to check the registration status of a record and be notified when registration is complete using a protocol. And before this organization existed, there was nothing. So we just said, well, we'll just use web sub webhooks to do it. That's what the webhooks is. And it's the way that we currently when we demo to people, how does OpenCRVS and MOSIP, how does MOSIP know when a birth registration happens? It's via the webhooks. In the future, all the DPGs would like to work towards something like this, where we're all listening to this. So we've done this with OpenSPP, the social protection platform you may be familiar with, and they can listen to us through this. MOSIP have not yet adopted this, and we don't know what their strategic vision is, whether they will, because they also have their own APIs and they're happy enough with our webhooks. But we'll see what happens. There's obviously a lot of people in this DPG world, and they've all got their own backlogs. They're all very, very busy, and it's about getting people together to standardize things like that. It's a nice initiative. Webhooks is web sub. It is a standard. It fulfills the need at the moment. But obviously it's great. Anybody can subscribe to OpenCRVS webhooks, and you see them in our documentation as well, like how you actually subscribe to a webhook. So you might find that is something that you have a downstream system, passport system, which would like to use the webhooks to know when a registration happens. I'm going to come to an end of talking about these modules and get more into some back-end detail in just a moment. Couple of other things here to mention which are not microservices. Do you remember I said that there's some folders here which are shared libraries? The most important one is called Commons. So Commons, you'll notice a lot of functions that all the microservices, this is basically just a TypeScript library of reused code that every single other microservice uses. For example, to check the JWT is authentic, logging, some other stuff. If there's a strong argument to put it in here, we'll do that. If we think that every single microservice is going to want to know how to get certain types, common types, then they're all in here. Where you see the customizations that we've done to some Fire things, they're all kind of here. Interesting place for you to observe when you want to find what we did, why we did certain things. Comments. So there's no Docker container there. It's not a microservice. It's just a shared TypeScript. Components is the Storybook UI component library, which you don't need to deploy. It's just there for developers to see, and they can decide which React components they want to use. There's a bit of a story around, again, a history around this. So, and explains a little bit idiosyncrasies in the React application. But front end, we'll talk about that in a different call. Data seeder, it's not a microservice, but this is used by the GitHub action to seed a server. So you know that you do that when you deploy to make sure that an empty server has a user in it you can use to log in, has the reference data locations in the database before you log in. That's what that is. It's run by GitHub. There is this. I don't know what it is. I think this might just be my VS Code, but I think this is nothing. Mobile proxy, whatever that is being deprecated. It may have been something to do with pinging things, or it's not a requirement. I don't even know if it's even in OpenCRVS Core. It could just be my local. Yeah, it's just my local VS Code. Mobile proxy. This is we're deprecating this. This was built years ago. This is nothing to do with OpenCRVS stack. It never deploys anywhere. What is this? Well, we wanted a developer to be able to develop something and then check it on their mobile phone over localhost. And so that's what this does. It uses ngrok to create a local URL you can browse to on your phone from your local computer to check how your user interface might, or the mobile experience. I don't know anybody who uses it anymore. We do a lot of our own mobile testing elsewhere. We've got browser stack, we don't need it, but it's still there. Maybe somebody might want to use it if they don't use browser stack or whatever. That's all of the microservices. So that's me covered that first requirement. And there's a lot to get through here, but we do have another hour. So the next thing we want to talk about is a basic API flow and for a query and mutation and how it resolve functions interact with the database. Okay, this is something which Riku would do a much better explanation than I will, but I'll do my very, very best. So in OpenCRVS Core, if you look at the code, you will see sequence diagrams folder. So if you click the sequence diagram folder, you can see lots of sequence diagrams about what's actually happening in the backend. So this will tell you what you need to know regarding the interactions. And if you were to look at the sequence diagrams in 1.4 and compare them to 1.5, you'd notice quite a lot of changes. And I'll talk about them a little bit when we talk about the API flow through the backend. So when you are submitting a registration, as I did previously, I showed you the GraphQL query, and it would do something like create birth registration. It would call the create birth registration resolver in GraphQL. Now, let's talk a little bit about our GraphQL history. So we started building this in 2018. Back then, GraphQL.js did not exist. You had to use schema files, and you'll notice that those schema files are still there. You know, we have not migrated to GraphQL.js. Technically, it still works fine, but we'd like to. It would reduce the complexity in the Apollo client if we did so. But that's a massive job to like refactor the gateway from using schema and to using GraphQL.js with nice types. That's what we want to do. But what is the business value of that? Well, it is developer experience. That's hard argument to win. So it works fine the way it is. We're continuing with it the way it is, but it would be nice long-term project to do that. Anyway, the GraphQL gateway has, as you know, queries and mutations, but we're not so strict on, you know, a query should just return data. Mutation should mutate data. Often you'll see mutations being used when it's actually a query. All right, you'll see a mutation being made in a query. We don't really bother too much about the differentiation there, which is technical debt. You know, that's again, it's affecting developer experience. It would be better if we adhered to that. But as you know, it doesn't. So don't worry too much about the difference between query and mutation in our gateway and our Apollo client. They're just kind of like requests. Then we have some of them cached, some of them not cached. Things like work queues, we're caching them and we're making like mutations. Obviously, we're not, like when we're submitting registrations, we're not. So we kind of, in that aspect, like we do pay attention, but we're pretty flexible on whether you're going to use a query or a mutation for something. So the gateway, you'll notice if you looked at, say, for example, the create birth registration resolvers. Let me see, search birth registration. Let me see, fetch birth registration. See, create birth registration. So it's a mutation, 9 times out of 10, we've put it in the right place, but you might find some technical debt where it's not in the right place. So we're posting data to the database for a new birth registration. And if you were to look at 1.4 and every version before that, you would see we build a fire object. And so we still do that. So we start building the fire object here, but then you would notice that we send it to OpenHIM. And OpenHIM would do the routing, because OpenHIM has a function called channels, and it allows you to dispatch events to multiple places. And this was kind of history of OpenCRVS. OpenHIM is an interoperability layer for external integration, but it can also act like an enterprise service bus. So we were using it like an enterprise service bus. And in 1.3, we were getting a bit frustrated with the length of time it was taking, especially as countries scaled. Like we were scaling across Madagascar, we're noticing these requests are taking quite a long time. And then we did some performance analysis and saw that OpenHIM was using up like 200 milliseconds or something like that for every single request it was making. And you can imagine that cumulatively, that would mean that reaction time when you click download on a record or submission, the user's waiting. And they don't need to wait if we decide to use OpenHIM only as an interoperability layer at the external side of our stack and not as an enterprise service bus. So you'll notice a lot of differences in the sequence diagrams between 1.4 ones and 1.5 ones. You'll see that in 1.4, we're doing a lot of back and forth to OpenHIM between different microservices. I was talking about how you'll notice the fire bundle is created, and then it will be eventually dispatched to the workflow service. Okay, that's what happens in the back end. Everything goes to workflow for creating a registration, and workflow then decides to distribute it out to manage the state, the action on the record, change the state, track everything and audit, and then go to search, go to metrics, as I was explaining before. Previously, you'd have seen us bouncing back and forward between OpenHIM for all of that. So for every single request, it was making like 3 or 4 or 5 calls to OpenHIM, and that each one you're waiting 200 milliseconds. It was taking 2 or 3 seconds to 4 or 5, 6 seconds to submit the record. And in low connectivity as well, it just compounded the wait time. So we deprecated OpenHIM entirely from OpenCRVS. So this answers your question about OpenHIM mediators. We don't care about OpenHIM mediators anymore. So 1.5 came out a couple of weeks ago. I have not updated the documentation yet to fully remove mention of that. And in the migration notes, I'm still writing them. So you have kind of like a beta access to it. Like it's there, but you'll notice we've made no public statements about it yet because we want to make sure the documentation is absolutely right. And then we'll say mid-August, 1.5 is released. And you'll notice lots of migration notes saying, we no longer use OpenHIM. So if you've written an OpenHIM mediator, you can still use it. You can easily put OpenHIM into a Docker container and put whatever mediator you've built on top of it, and it will go through OpenHIM to Hearth. But we don't see any need for it in our countries where we work. Nobody's ever asked for it. Our APIs that we already have do the job well enough. So from a civil registration perspective, if you want to integrate with healthcare, a hospital, you can just use our event. You can use our event notification API. This has got nothing to do with OpenHIM. It goes to our gateway. There's no need for OpenHIM at all, really. But if you have any questions on that, please let me know. But you'll now notice in 1.5, OpenHIM is not part of OpenCRVS anymore. And instead, you notice it's a lot faster to submit records and a lot faster to download records. So we've left it in a sequence diagram just to kind of show what's happened, because people might be like, where did OpenHIM go? Well, it used to be something which is a big part of it. Now you can see that it's not. You can see that nothing is talking to it. And therefore, what we have said in our release notes is we've moved it out. We haven't yet got rid of some OpenHIM dev database. The people may have log data in here that they want for whatever reason. Audit trail, I don't know. But we'll say, look, from 1.7, we're going to get rid of this. So you've got until then to dump the data, put it somewhere safe, and then this will disappear. Should it be necessary for you? But I don't think anybody's going to care, quite frankly. So in workflow, you can see what's happening. Well, if you followed these fetches all the way, and you went to workflow and you looked at the endpoint, you'd see that the registration goes to Hearth, and then we will go to search and search for duplicates. If there's a duplicate, what we do is we get the fire IDs of the associated duplicates and we save them into search. We say, there are these potential duplicates. And that's what the work queue would then show. It shows you that icon that says duplicate. And you go, oh, I've got to manage those duplicates. Click that button, then we go and we search, get the full duplicate records from Hearth, and then you can compare them side by side and say, okay, this is a duplicate, reject it. This is not a duplicate, and remove the fire ID that says it is from the search. So it will no longer think it's a duplicate. That's how that's working. So you can see, follow that code. Then we do this request to country config. So we're happy now. Sorry, I've skipped documents. So we've checked for duplicates. That's the first thing we do when a Hearth registration happens. And then we uploaded the attachments to Minio. So you'll see those attachments going to Minio via the documents microservice. And then we're happy to register. And if there's no duplicate, we're happy to register it. And then we call the country config microservice. Why? Okay. So country config microservice event registration service. Because countries want to customize the birth registration number. Actually, this is not correct. That's later. I'm sorry. I think this is to customize the tracking ID. My mistake. What we're doing is we're calling a handler to customize the tracking ID. Here, countries wanted to change that. It's alphanumeric string. Some people were like, we want to use a different format for the application ID. So you customize it there. So we generate whatever tracking ID you want. Then the workflow will get, because inside the bundle, it will have the user ID and fire ID for the logged in user. Remember I said the users are on the user management microservice. So these are our IDs, but in order for us to create an audit trail in Hearth of who did the action on a document, we have to do it in a far standardized way. So we can interoperate as a standardized data layer. So what's that? Well, the audit trail is a fire task. So if you were to look in our MongoDB, you'd see a task collection. This is all the information about what action happened to a record for various purposes that people have developed. So how much time was spent on the record? I just clicked on one randomly. Here we go. Here's a tracking ID. Here's a birth registration number, business status. It was registered. And there'll be somewhere here which will say who did it. Registration last user. It was a practitioner, right? A fire standardized way. So users in our user management database for OpenCRVS have a representation in fire, and that representation is practitioner. Exactly, like a doctor, registrar, doctor, they're members of staff, right? They do things. So you can see who is an interoperable way of finding out who the name of the person, what did they do, and what was their role in the practitioner role, and what tasks did they do, and the task history. So there's a history of tasks on a record. So workflow creates all of this stuff in Hearth, and that is what you see if I log out and I log back in as that registrar where I made a registration. So I'm looking at this record. At the moment, I can only see what's in Elasticsearch. There's a couple of things which are there, but we've grayed them out because we didn't want to display on screen PII. But if I download the record, what I'm actually doing is I'm going to Hearth via the gateway, and I'm getting the audit trail, which is all in Hearth, these task histories, what happened to each, what were the actions on the record. So the status is in Elastic, the actions are in Fire. These are all the actions. These are all the tasks that happened to the record. So this is your audit trail. Who did what? Where were they? That's that. So you see that happen here, where getting the user's practitioner ID. We're getting updating that bundle with the user's location in a nice fire task. And then we've got it all ready, and then we send it all to Hearth. Hearth says, yes, success, we've saved it. Great. So as far as Hearth's concerned, the registration's made. Now we need to do our kind of analytics. So post to the metrics microservice, and we say take out the non-person identifiable information, store it in influx deep data. And we're getting some more requests to Hearth and metrics for some information that it might need. I think this is to do with, see it says location levels 432. This is to do with the statistical information that a country has. So when it's trying to create a completion rate, so if I go to Farajalan, the metrics microservice is trying to calculate the completion rate. The only way it can do it is by knowing what reference data we've configured in the system. So if we look at the country config microservice, you probably remember when you were configuring OpenCRVS, location CSV, where you put in all the administrative locations. And then you probably remember the statistics CSV, where for some of those locations, down to state level, you know what the population is, disaggregated by gender, and you might have an individual crude birth rate. So the crude birth rate is a ratio of how many people are born per 1,000 people every year, I think. Yeah, every year. How many people are born per 1,000 people in a ratio? Statistical departments generally have that information. And if you're in a Sri Lanka or India, they've probably got very detailed information. But lots of countries don't have that at all, like down to a very low level. If you're working in some of the countries where we've been working, they'll have no idea what the population really is at a small area location level. So we have kind of hard-coded location levels. I think it's currently up to 5. It's possible to have up to 5. So wherever you work, if there's going to be a 6th or a 7th or an 8th, that's currently not supported. You have to do them with like text fields. It's possible for you to have statistical data all the way down to 5 locations, but most countries will not give you it. There's so much data to collect, to give to you. They might just give you to state or district level. So the metrics microservice doesn't know what levels have this data. So it needs to check with Hearth and say, okay, I'm about to save this registration. Do I create a completeness rate for the state? Yes, I do, because I've got statistics. Do I create it for the district? Yes, I do. Do I create it for some sub-district, like a union, or thinking of Bangladesh, there's like a tiny little thing called a union in a upazila in a district in a province? No, because I don't have union statistics. So that's why it's making these requests. And it's writing its metrics to influx. And you can see various things like changing the estate from one state to another. You'll see some code in here that might say waiting external validation. And this is where, as far as OpenCRVS Core is concerned, a registration's been made. It was valid. The metrics have been tracked. The attachments have all been uploaded. It's validated. We think this is ready for you to officially give it a birth registration number. That's when we call country config again. So you'll see another request all the way to country config, and that is where we are doing this event registration service. Right, now you can customize the BRN. And inside that bundle, you'll get everything. You'll get the full task history, you get all the fire IDs you need to look at any attachment, the location, who did what. So you could use it because we don't know, countries might decide we want to do a BRN, which is, and we've had this recently in Somalia, where it is a couple of characters in Somali for birth, plus a abbreviation for the district where the child was born. So we need to get the fire ID for the location, use the event location API, quickly get the location. This is why we're not moving location into this kind of, got no plans to put that into a single composition, NoSQL entry. Keep locations out so we can do quick things like this. Then the year of birth, then the tracking ID. But you might want to have something like the initials of the registrar in there. I don't know. I mean, every country is different. So you can customize the BRN here. It's an asynchronous call. You don't have to respond. Why is that? And what happens if you don't? Well, if you don't respond, the UI will look like the registration has disappeared unless you enable what's called the external validation work queue. This will create another work queue saying waiting for external validation. And why did we do that? Because we worked in a country that said we want to pilot OpenCRVS alongside an existing civil registration system. And every registration that OpenCRVS makes, we want to get sent to our old system. Because that's what we want to do. So we made this queue and we said, okay, you can use that endpoint to submit the data to you can use the, apologies, you can use the, this endpoint, the event registration endpoint in country config to save the data to that system. And but we don't have any control of that system. It's a legacy system. It sometimes is offline, which is why people don't like it and why they want to upgrade. And the experience of OpenCRVS is hampered by that, but the country wants to do it, fair enough. So we'll show it in a work queue saying, this has been sent to an external system and we're waiting for a response. When that system has saved it, it can call it back to the return, the confirm registration URL. So it can comment that out and it could call this anytime it wanted to when it's finished doing whatever it's doing. And then that record will move from waiting external validation to registered work queue. So that's what that is and what that enables. Now, this was something which was requested by a country 6 years ago, and nobody's ever requested it since. So it's highly likely that there may be issues there, technical issues. So if that ever happens and you're being asked to do it, work with us and we will help you if there's any issues you encounter when using that feature, because it's not a feature we talk about. You won't see it in a documentation. It's not something we advise, but it's technically possible. So that's what's going on here. So you'll see that that's all done. We then get the BRN back, we assign we stick the BRN on the record, and we say fully registered. Then we update search, and we say search, your status is now registered fully. And we post a notification to the mother and father. We send them an email or SMS message. So that will go to notification microservice, that will go to country config, the email will get sent, SMS will get sent. And then we essentially respond with, we can update the webhook. Yeah, we dispatch the webhook. So then MOSIP can listen to it and go, great, there's a registration, here's a BRN, we can make a national ID. Or any other system. We can make a passport, we can do anything else. So that is the back-end flow for creating a birth registration. So there are lots of other ones, like correcting a registration, archiving one. The naming isn't very logical, but you'll notice that, of course, different users do different things. A field agent, all they do is submit a declaration for validation. So a lot of that stuff doesn't happen. It's just as basic. Here is my draft fire composition in Hearth. Here's a Elasticsearch entry with the declarations being made by me as a field agent. That's pretty much it. The registration agent will do like a lot of workflow. Let's move that draft declaration from a declared state to a validated state, but we're not going to register because that only a civil registrar can do that. And a civil registrar is the one where you see that full flow. That full flow is possible. So the variations in between for different users, different permissions, but that was pretty much the full flow of what happens in the back end for registration. So I'm conscious there's not been many questions. I've talked quite a lot about fire in this conversation. I've talked about database collections. I've even talked a little bit about migration and how the patient details are saved, because you could see that happen, right? You could see that they all go into different collections when that Hearth does it. Hearth does this magic. You can send, Hearth is really cool, this fire database server. You can send a fire composition of anything fire, and Hearth just parses that JSON and knows what to do with it. It will save it into the right collection. So that is all done inside the Hearth tool. We don't really have to care that much about it. We just post things to Hearth, and Hearth does the actual MongoDB storing, as long as it's fire. As long as it is fire and it can understand it, it will save it. If it doesn't understand it, it will just reject it. So kind of covered everything in that list. So shall we have a bit of time for some questions or anything you'd like me to talk more about in terms of the back end?
To anything, yeah, Evan. It was a lot of information. Yeah, it was good. To anything.
No, like we covered anyway, the entire list anyway we covered. But in that API flow, can we, then the sequence diagram, can we go through the code wise places, exact places where it navigates those areas would be better.
Yes, sure. We can start to do that. This is I can do my best. Maybe something that better Riku did with you, and actually you can see the fetches, the types that change, etc. Now, my question back to you would be, you're going to have requirements from countries to do certain things. And that requirement could be things like, we want to make a new status between two of these kind of core statuses, or we want to make a user who's able to interrupt that status and do something different with it. Customizable workflows, right? Because that's really what this all is. It's the workflow. And I don't think that you would ever need to do that on your own. You should ever do it on your own, because you would be forking OpenCRVS in quite a fundamental way that would make it very difficult for you to get an upgrade. So if you had a specific need, like say and I'll show you some examples. So if we look at our project, this is really all about contributing to core, where this becomes something that you need to know. At the moment, I'd say if there's not a requirement for it, there's better things you might want to know that would actually help you in the immediate short term. So for example, the station user. So this is a request which has come from a project in the Philippines. And the description might be not very great here, because you'll notice it's still in the backlog. So a business requirement has come in from a country, and we need a new status between declared and ready for review by a registrar. Where config equals attestation on per event for all declarations within the office on submission, set status to ready for attestation. And there's a new user called an attester user, and they're able to log in and perform an action to update, say, ready for review. So it's almost like there's some bureaucratic process between registry applications that come in from the field. Somebody almost has to look at it and sign it off for validation. It's probably enshrined in their law that they have this, that they have someone who has to tick a box. So this request comes in from a country, and you might have something similar. You're like, we've got this status change we need to make. Now, if you need to make a status change, that's very fundamental. If there's a workflow change that has to be made, it's very complicated to do that yourself, and very complicated for you to do it and then ensure that when you upgrade OpenCRVS, you don't have conflicts. So when this core change is required in anything, your first approach should be write the business analysis in an issue on GitHub, and we all get together as a design team. So there'll be user experience designer from our side, a technical architect from our side, and a technical architect from your side, and a business analyst from your side. We have a meeting and we talk about this, we flesh it out, and we decide how is it going to go through a design process. Who's going to take on the technical architecture design for that? And then it's very important for you to follow this code all the way through. with Riku. That's when that would become critical to do that sort of work. And you go, okay, I'll make a change there, I'll make a change there. And the designer, either your designer or our designer, might say, okay, here's the user interface. This is what's going to happen in the work queue. There's been requests for, I passed your request on the other day, yesterday, Shannon, for Figma. How do we mock up things? And so I've reached out to John for that. John's in Philippines right now, so he'll be back next week, and I'm sure he'll have a response to you on that. Your designer will be like, right, okay, I'm going to mock up this design. The architects work together to work through the tech tasks. We write through the acceptance criteria, and let me show you what an eventual ticket looks like when it's ready for build. So here, okay, ready to build. So it would end up with a user experience design, links to Figma with the design changes, acceptance criteria that the quality assurance team need, because they'll be saying, okay, when I'm a registrar and I do this action, I expect to see this result. And you'll see dev tasks, which you will have written with Riku, which say, go to this function or that function, add the type appropriately, refactor it in this way. And each one of these is like a tangible development task, which is like, say, can be done in a day or two or less. Then it's ready to build. Because and so you can do all that analysis yourself. You can write these tickets all yourself and just submit a complete issue, right? So what you should do is literally look through the code. That might take you time. And the request you're asking for me is click through all the code. That's best done when we actually have a job to do, like this, with Riku in a session dedicated to completing a job, specific job, because I think it would take quite a long time to do that. And probably on a case-by-case basis will be very different, depending what you're going to do. If you're making a status change to record correction versus making a status change to registration, entirely different flow, entirely different code. So hopefully that would probably be enough for now. And what you should,
I get it.
What if you do have a requirement that you're aware of that involves it, definitely make an issue and at us in it. And you don't need to put that much in it in the beginning. You know, if you look at the ones which just say backlog, they might be like really, really rough. We need to do this thing. That's it. And you might put a flag on it for whatever country you're working on. And you might say, I think this might be a big thing to do, or I think it might be a small thing to do. That's enough to get the conversation started. And then what will happen is it will appear in our backlog. And you should also notify us. You should say, we've made an issue. We need your help. It will go into the backlog. So it will not have a milestone. It will not have a release number yet. Once we've done the design and we've kind of triaged together about how we're going to make it, what areas of the application it affects, when you need it for, like you might need it very soon to hit a deadline. And then we say, great, well, let's discuss putting it into an earlier release. How are we going to do that? Which developers can you supply to develop it? Obviously, Revolve, you guys can do it all yourself. You know, you don't need us really to develop it, but every organization is different. Some organizations need much more of our support. Maybe you just need our support in the design phase. Now, releasing is a very interesting question, which we're working on. So currently, we have been operating relatively independently. You know, the countries where we work, you know, we can decide what we're putting into the release. But now, of course, we have a bigger community and we need to have regular releases. So what we're working on, like really dependable gates for you to get your tickets designed and built and in. And so we're working on a release train, which you probably heard that concept, where you will have a calendar and you'll know that if we get our tickets designed and architected with tech tasks, we can submit them for development. And if we have our own quality assurance engineers, if we can get those acceptance criteria tested and thing developed and automated tests written, and we can get that in a pull request before a certain date, when a release regression period would start. It's like you're joining a train of continuous regression testing. So you know I've got to get my ticket done and quality assured and test written, and it will drop before the release train of regression kicks off. I can guarantee I'm going to get it in that next release. And we try to have these at around 8-week intervals. That's our ambition. We want to get there by the end of the year, that we have this kind of 8-week interval release train. Please bear with us while we get there, because we are a growing organization building a community. For anything you need for Tonga or wherever you're working on in the short term, we can have a side conversation about that and see what we can do in the meantime.
Okay, that's fine.
Yeah. That is good. I think, yeah, that's one point we wanted to discuss, how we can do the maybe design and do the pull request. So that covers it, I guess. But for minor fixes, maybe minor features, how do you suggest we approach?
Anything that has to happen on OpenCRVS Core is
Yeah.
the same approach.
Okay, so in terms of the country config, we can
Do whatever you want.
all right.
Yeah.
Okay. So I guess the sequence diagrams also helps in what Tua was mentioning before, so we can refer that. That's all good. A few more questions, Ian.
Yeah, of course.
Now, yeah. So when it comes to this, coming back to the OpenHIM, so is there anything in place of that we can use for audit purposes? Like, for instance, when we integrate it with external parties to monitor those requests coming in and data going out, do we have
Yes.
anything?
Yes. So it's like the cool thing about OpenHIM is it looked a bit like SQS, and you could see all the requests. Yeah, that was nice.
Yeah.
We don't have anything like that. But we have Kibana. So in Kibana, when you log into Kibana and you click observability logs. So if I go to log into Kibana, let me see. I mean, you're just looking at server logs, basically. So that's all we have. We have talked a lot about message queues over the years, and we've been involved in projects where things like RabbitMQ and Kafka and these sorts of things have been in place. And our opinion is that for all the benefit of having that view, the complexity added outweighs the benefit of just being able to see the logs. We don't see the need to put one back in. That's our current opinion. So really open to discussion on that with our technical architects. So we could talk about that as a community, you know, because adding in a message layer in between all the microservices, as we see, it impacts performance. And if you can monitor logs well enough, and you have error handling in place, if you really want to, we have the way in Kibana to monitor any integration you like to any microservice. And you can hide all the other logs. You just look at the logs.microservice. So that's a good enough audit trail. But everyone will have a different opinion on that. And that's currently where we are. You know, for a long time, we're thinking, oh, let's put BullMQ or RabbitMQ in. And then we thought, you know, do we really need to? On the fence. Sorry, let me just log into Elastic one, please.
Yeah.
Log into Kibana, sorry, I should see. I'm not sure I even know the password for this one. Oops. So whatever, I mean, I imagine your API request, well, all of the API requests as per our documentation go through the gateway. So if you log in as system admin, and you create a integrating client that can use the event notification API, and they call the event notification API. What they're doing is they're sending a post to gateway. And the Kibana, if you go to observability logs, you can use the search and create search queries to really only search for requests to gateway on the event notification API endpoint, and you have your audit trail. So the way you do that is you type tag : and then, for example, gateway, and I'm only going to get logs from gateway. And then you can work on that query and search only event notification endpoint. So this does a good enough job of audit trail of that. And you can even stream them live in testing. So you can then do a post and you'll see it pop up. Also, every single request to an API is tracked in Hearth. So if I log in and you see the audit trail here, if a client used the record search API, so a client used the record search API to search a record, you will see in here the name of that client, whatever external system it was. So the audit trail here audits for every record who has access to the personally identifiable information on that record. So if it's because you're auditing who's looked at PII or who's manipulated PII, it's here. And also you would see that the event notification was started by a hospital system. And you get a little box icon you can see. You can practice that now. So in your own, that's always been there since 1.3, I think. So you could use the event notification API. You could submit a record. And there you can see the audit trail, DHIS2 submitted a record. So we have that kind of capability within the UI as well.
Right.
So because of that, we're thinking if audit's the only reason, do we need to have a enterprise service bus adding complexity, adding latency? Don't know.
Understood. Yeah, but this is like when you had to go into a particular event and then see the history.
Yes, but these are also users. So if you can click on any user and you can see everything they did. So you'd click on the DHIS2 user and you'd see everything that it did on every record.
Right.
So you could browse for it that way, because obviously it's harder to do it from the record out entry point, but it's easier to do it from the user entry point in that respect. So yes, this is like what OpenHIM used to do in a sense.
That's good. Yeah. Yeah, sir, but you mentioned if it's I don't know whether it will be the case, but if it's needed, you said that we can code back OpenHIM just for external integrations, is it?
Yeah, of course you can. So you could take the block for OpenHIM that you have in 1.4 and just put it straight back in, and you are using it any way you like to go straight to Hearth. You just put the you make your own channels direct to Hearth. But the thing is, what you're doing there is you're entirely bypassing this OpenCRVS audit trail UI and manipulating records directly in the database potentially. So use with caution.
Sorry, I didn't get that.
So you can put OpenHIM into your stack. And if you look at 1.3, 1.4, you'll see OpenHIM is kind of like can communicate directly with any microservice, right?
Yeah.
In any way you want. So you're basically putting in another API gateway, which must be secured and whitelisted. And you could potentially communicate directly with the database via Hearth. So OpenHIM is compatible with our stack, but you use it at your own risk. That's what I'm trying to say.
Okay. Understood.
See, you can put the block back in, but be aware it's powerful and it can do anything, and anything on your data that may or may not be reflected in the OpenCRVS UI, depending on what you do, because you could literally do anything. You could change these fire objects to be anything you wanted.
Right. Yeah, I guess like those kind of big changes we will always consult you. So yeah.
Yeah, if you think you need to put OpenHIM in, let us know why you're thinking that, and maybe we can find a way that you don't need to do it. Because we've got quite good APIs already, which are fully supported. Like, for example, record search.
Yeah.